Hello everyone. So let's start the very last topic of this module 3, topic 7. So in topic 7, we are not learning new stuff, but based on what we have learned in the previous topic 6, we are going to look at some other practice examples so you can better understand by completing a little bit more exercises. So let's look at topic 7. Some data I'm going to reuse what we have used before, but let's start with a little bit new data. Here I named it as sales data. So we have 3 tables related, and the relationship is pretty straightforward. Here sale, line item, and item. So one sale here, my sale table, actually we have 5 sales. Each sale we are selling multiple products. So we use the term line item. So here is my line item. For sale number 5 given here, we have 1, 2, 3, 4, 5 lines. Why we have 5 lines? Because each line is describing different items. So here item number, the blue color, the item number is given, and the item number is given 10, 11, 12, 13, 2. But all those item details like item name, item type, and item color, you need to link this item number with the item table. So here in item table, item number is a primary key, and we can find the name, type, and the color. Since we have used the previously similar examples, invoice has many lines, and the lines are related with the parts. I will not add more details, but you can see line item is associative entity, and my item to my line item, there is one-to-many relationship. My sale to my line item, again there is one-to-many relationship. So we have foreign key, 2 foreign keys. Here my line item, sale number, item number, sale number is a foreign key referencing my sale number primary key. My line items, item number foreign key is referencing my item's item number primary key. So before we develop any SQL statements, let's look at the SQL for creating tables and insert data first. All this script is given in your note. So if we look at the note at the beginning, you will find these statements. So let me just briefly mention about those statements. So here we drop 3 tables if it exists and recreate my sale. What is primary key? Sale number. And the table, my item, we have a primary key item number. But the associative entity or associative table, my line item, we have a foreign key sale number references my sale, foreign key item number references my item. But note that primary key is composite primary key, sale number plus line number. Line number is a sequential numbers like 1, 2, 3, 4. So given this table, please run this to make those 3 tables, and then I also add the insert into statements for all those 3 tables. So by running this insert into tables, you can populate all those sample data set. And then after you are done, you may have this all sample data, and then we are ready to move on. So let's move on to the first question. So here the first one is, let's look at the basics of join first. So since we are using 3 tables all together, if you run the first test, let's start from just a list of 3 tables. You already explained in the previous topic, you will get a lot of data. That's just random match of all 3 tables. So those random matches are kind of Cartesian products of all the data set, and they are almost meaningless because nothing is matched together. So to make this data meaningful, we need to add join statements. Since we have 3 tables, we need to add 2 join statements. As I described already, the sale number matched between my sale and my line item, and item number is matched between my item and my line item. Okay, so as we have done so far, let's use Visual Studio Code and then let's run this basic join statements. So everything we want to select from 3 tables. Again, this my sale and my line item sale number is foreign key and primary key. My item and my line item number is foreign key and primary key. So using this basic join statements, let's look at the result. Okay, so let's execute it, go, and you can see now the first sale, and in the middle it's a line item, at the end it's item. So given one sale, for example, let's look at sale number 5. All the sale information is given here, kind of repeating, and we have 5 lines, and there is item associated with each line. And for further details about item, we join this item number with the item table. So here are some details about item you have stored in each line. So that's how we can merge all 3 tables together and make a meaningful information using join statements. So given this, now let's move on. So here is the first practice query. List the name of item, quantity, and the value of items. The value of item means here it's described as total, but it's nothing, but it's a kind of derived value, and you can obtain this by multiplying these 2 columns, line quantity and the line price. Okay, so for each item, so by looking at line item table, you may find the line quantity and the line price, and you can multiply these 2 values. Again, the derived value is not given in the table, but you can always use mathematical operations. So here what we are looking for is items sold on certain date. So if you look at first the item table, you cannot find any information about sales data. So although here is a list of items, there's nothing you can relate with a specific sale, particularly sale date. So you may want to go back to line item, but here in line item, you cannot find the date either. But in my sale, finally we can find the information about sales date. So here sale date, if you read here, the last one is only one sale that has been done in 2025, January 16. So in this my sale table, by reading this sale date, we found one sale number 5 that has been done on this date that we are looking for. So using sale number 5, now can you relate this number 5 with the item directly? No, we cannot. But we know that here my sale first is linked with my line item. So by looking at this sale number column here, you can see number 5 is matched. And when it's matched, you have actually 5 line items. So each line item we have different items. So we have an item number that we are looking for, 10, 11, 12, 13, 2. But again, we do not have enough information about item, like item name, line quantity, and the prices are given, but we do not have the item name. So we need to match this item number with my item's item number. So for example, if it's a 10, by matching 10, we know that it's a safari chair. So we can find the item name by matching this my line item's item number with my item's item number. And if you find one item, then you can now multiply 2 numbers, line quantity and the line price, from my line item table, and you can get the total value. So from this example, how many tables we have used? To get the sale date, we have used my sale table, and we link my sale number primary key with my line items foreign key sale number. And again, to get more item details, particularly item name, we link this my line items item number foreign key matched with my items primary key item numbers. And the other information we can find my line item by reading line quantity and line price. So basically we use all 3 tables. And when we use all three tables, we already know we need to use two join statements. So let's go back to Visual Studio Code. And let me start with what we have done before as the baseline. So we are going to use the same three tables given here. And therefore, we need the same two join statements. But what we are interested in is item name, line quantity, line price. And we need to add one more. So instead of star, let's say item name, line quantity, line price. And since we are interested in the total, the value is line quantity multiplied by line price. So let's use this derived value, and I'm going to use alias total. There is one more condition. What's the condition? We need to add one more condition about the date. So we could read the data from sale table. So sale date is given as 2025, January 16. So let's add this one more conditions. Okay, so let's execute this. Click go, and you will get the result. So here is a list of item name, and here is the total value multiplication of second column and the third column. Okay, next question is about reporting. So reporting all clothing items, that's type C items, for which a sale is recorded. So when we want to check whether there is a sale or not, you may remember we have used the very useful keyword exist. So if there is an exist keyword, it's going to be followed by select statements, and we can check the existence. So let's look at the data first to get some better idea. Okay, so in this data, we are looking at the item, and the item type is given. So item type C is clothing. So there are several item type Cs, but not all those items have been sold. So we have to check whether this item has been sold or not. So for example, I will look at each item. So I'm reading, and I got this first item number 6, that is type C. So now I want to know whether this item number 6 has been sold at least once. To do this, using this item number 6 given here, I will go to my line item tables, and I will check this item number columns. So I found number 6 here in the second row, and if there is no more row, that means this item has been sold just once. So it's been sold just once. But anyway, it's been sold. It doesn't matter whether it's once or twice. As far as the ID, item number is shown in this my line item table, that means the item has been sold. Now, if you look at number 7, actually for number 7 as an example, although it's clothing, but if you read these item numbers, you may not find the number 7. So that means this clothing has never been sold. So like this, for each item number, we have to check whether we have at least one row matched in this my line item table. So first of all, remember there is a keyword exist, and the exist is always followed by select statements. So the select statements we want to type here is select, and which table we have to look at. It doesn't matter which column, but we want to check from my line item table. But we need to specify one item number. So particularly where we want to check item number, and the item number is given as we don't know. Why? Because when we read each item, the item number is keep changing. So therefore, we need to specify this item number depending on which item we are reading from outside. So what this means is, in front of this exist, we have to write down another select statements. This time, I want to see item name and item color from my item. So let's start with this select statements. Item name, item color from my item. But when I look at one item, The first of all, let's start with each condition, that is item type. So we are looking at only item type equals to C. So let's type this condition first. And then there is another condition. What's the other condition? The other condition is that we have considered here. So after exist, we have this select statements. And now we can answer to this question mark. What would be the item that you want to check? That is from outside my item table. So here, as a correlated subquery, we can receive the item number from outside my item table, and then it's going to be my item's number. So again, this item number you receive from outside here, and it's going to be assigned inside item number. This item number means, actually we did not use qualifier, but the meaning of this item number here is my line item's item number. Because if you do not qualify this item number automatically, referencing this my line item, I did not include it here. So when we read each items outside here, this item number will be passed inside, and this item number will be assigned, and it will check it. And the exist keyword works when there is a 0 row, this whole part will return first. But if it returns more than 0 row, 1 or 2 or 3 and so on, the condition itself would be true. So the highlighted part is a Boolean type condition, either true or false. So you can just run this query to get the final result. So let's run this, and then you will get this result. So these 1, 2, 3, 4 items that have been sold, and it's their types are clothing. As a practice, similar to the previous topic, can we convert this exist to in statements? Can you make an equivalent statement? Yes, we can. So if you want to use in, instead of this select everything from line item, actually from here, the starting point is a bit different. Not start, but we are interested in making a list of item numbers. So item number, we have to list up here. You may find some duplicate numbers. That means this item has been sold multiple times. But anyway, this is the list of items sold because it's from my line item table. So if you want to make it, it's not necessary, but if you want to make it as a distinct item number, you can always use a distinct. So anyway, we are ready with this list of items that have been sold. Now, if you have this list, now let me make it inside parentheses. How can we use this is, again, outside we are reading my items, item color, and the same condition, item type, C is used. So let me just copy this part. But now the following condition is, instead of existence check, we have a fixed list of item number. Therefore, here what we need to do, we have to use a keyword in, and in is followed by this list. But don't forget, in front of in, we have to specify which column. So here, my item's item number will be compared. Whether this item number in my item is in which list, the list that we made. So if you run this, you will get the same result here. So if we compare these two equivalent statements one more time, these two are subqueries because we are using two select statements. The first one is correlated subquery because each item, when you read this inside, the existence logic will be rerun. So every different item numbers, we need to check whether it exists or not. In the second approach, we already have just one fixed list of item numbers that are shown in this my line item. So it's not changing. But outside, by reading each item, We just compare this outside item number is in this list. So this inside select statements is not related or correlated with outside select statements. So the first one is correlated subquery, but second one is non-correlated subquery. Okay, very kind of similar example, but as a kind of bonus point. Report all clothing items type C that have not been sold. So how can we modify the current query? You can just simply put here in front of exist, not exist. Then, when this following select statements does not return any row, in other words, 0 row, the condition is true. Similarly, the equivalent one is not in. So not in this fixed list of item numbers. So if you run either of these select statements, you will get the same result. So just let's run the first one. So if you run it, you will get the result that's matched with the items that have never been sold, but they are clothing.